Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to find the time t in a compound interest calculation. Alright, let's consider the following problem. Chris invests $2,505 in a savings account with a fixed annual interest rate of 2% compounded continuously. Question: how long will it take for the account balance to reach $2,768.45? Okay, to get started, let's go ahead and identify the relevant information. What are we given and what are we trying to find? Okay, so let's do the identify step. Alright, so we're going to start with what we know. What are we given in this problem? We know the starting amount. The starting amount that Chris has can be represented by the variable p, which stands for principal. Okay, so the principal is $2,505. We also know the final amount that Chris will have in her savings account. So the final amount, we're going to represent it with the variable a, is also known as the balance. A is $2,768.45. Now, what's the interest rate in this situation? The interest rate, we can represent that with the variable r, and r is 2%. Now, this is a part where you want to pay close attention to. Whenever you're computing or carrying out any calculations involving compound interest, the interest rate will be given a percentage and you have to convert it into decimal form. Now, how do you accomplish that? You accomplish that by simply dividing the percent value by 100, which is equivalent to moving the decimal point 2 places to the left. Okay? So if you move the decimal point 2 places to the left, 2% is equivalent to 0.02. Okay, so quick reminder, do not forget to change your interest rate from percent to decimal form before you substitute it into the appropriate formula. Okay? Alright, so we have starting amount, final amount, interest rate. What do we want to find in this problem? So let's write down our want. What do we want? We want to find how long it will take. Okay? So how long will it take to grow her money from $2,505 to $2,768.45? How long will it take? This can be represented by the variable t, and that is an unknown. Okay, so we're done with the identifying component of the problem. Now let's move on to the next part. Let's model the situation, which I'm just going to give you a visual of the scenario. So we're going to use a graphical model here. Okay. Now what we have is an exponential function that's growing continuously. So let's make a sketch. We're going to be starting from a particular value, the principal or starting amount. The starting amount is 2,500. This is not drawn to scale, okay? So let's just say that's $2,505. And the goal is to grow this amount to a target amount, 2,768.45, okay, at a future time. The growth is going to be an exponential growth, so we just draw an exponential function which has upward opening concavity. So something like that. It's just a general sketch. Okay, so the question is, how much time will it take to accomplish this growth? Okay, so what we're looking for is the time value where our account balance is going to be $2,768 and 45 cents. So T is the unknown. Okay? All right. Now, let's write down an equation. Move on to the equation step. Now, what is the equation that we need in this particular problem? Remember, the growth is continuous. There are two types of formulas for compound interest. We have the one that's k times a year and the one that's continuous. Okay, so for continuous, the formula that's applicable is final amount A equals the principal P times the irrational number E raised to the RT. Okay, so this is a formula that will guide our problem solving process. Okay, we now have the equation. Now we're going to go ahead and substitute. We're going to substitute our know and want into the equation. If we carry out the substitution, we're going to have the amount A is $2,768.45 equals the principal, which is 2505 times the irrational number E raised to the rate. 2% is equivalent to 0.02. We already did that computation. Times the time, which is unknown, so it retains its variable value t. Okay? All right. So now that we've carried out the substitution, we're going to go ahead and solve this equation for t. So what do we do first to isolate t? We are going to get rid of this coefficient, 2,505, and then proceed from there. To get rid of this coefficient, this number is being multiplied by this exponential component here. So in order to undo that multiplication, we're going to use the inverse operation, which is division. So we'll divide both sides of our equation by 2,505. Now let's go ahead and bring out our scientific calculators and carry out the division calculation. So we have 2768.45 divided by 2505. Enter. That gives us 1.1051. Okay, or 1.1052 if we're writing it to 4 decimal places. So let's do it right to 4 decimal places. So 1.1052, that is equal to, on the right side, these 2,505 divides out, and we're left with E equals 0.02 raised to the t power. Okay, now we need to power down this exponent. Alright, now our goal is to get t isolated. Okay, if we take a look on the right side, we have E here, and the component with t is an exponent. So what we need is a special function that can help us power down this exponential component here, 0.02t, and then we can divide both sides by that function with e, and then the 0.2. Okay, so what function can enable us to bring down this exponential component? We're going to use the logarithmic function. Okay, since we're dealing with a natural base, we're going to be using the natural logarithmic function. Okay, so we're gonna write down we're gonna take the natural log of both sides. So the natural log of 1.1052 equals the natural log of e to the 0.02t. Alright, so now what happens here is that on the right side, we can go ahead and enter this expression into our calculator. Okay, so we have it saved in our calculator before, so we just press ln, the natural logarithm, we can see it right here on the first column, 7 buttons down. The natural logarithm of our previous answer, second function negative, will give that to us. So what we're doing here is we're basically taking the previous answer and inserting it into the natural logarithmic function. Okay? Enter. Our answer is 0.099998. If we round it to 4 decimal places, it's going to be 0.01. So just 0.1. So we will have 0.1000 to 4 decimal places. On the right side, we can power down this exponent that we have right here. 0.02t can now become a coefficient of the logarithm, the natural logarithm. So we have 0.02t multiplied by the natural logarithm of e. Now we're going to use another property of logarithms known as the inverse property of logarithms. Okay? What you want to remember is that the natural logarithmic function is the same thing as log base e. Okay? So if you're taking natural logarithm of e, you're taking log base e of e. In this case, you see that the base of the logarithm and the exponent are identical, so they cancel out, and your final answer is going to be 1. Okay, so whenever you take the natural logarithm of the natural base e, you will end up with 1. Okay, so we're going to have 0.1000 equals 0.02t. The final step that will result in the isolation of t is dividing both sides by 0.02, the coefficient of t, and that will give us t equals, let's enter that into our calculators again. So we have our previous answer divided by 0.02, and we have 4.99994 if we round it to 4 decimal places. Is the time t is 4.1234, and if we round it to the nearest whole number, t is approximately 5 years. Okay? Now, so that's the answer. Let's go ahead and write down what this answer means. Let's write down the interpretation of this result in the context of the problem we just did. So what this t means is that it will take Chris 5 years to grow her money, from the initial amount of $2,505 to the target amount, which is $2,768.45. Okay, so this is what the answer means. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your studies of logarithmic functions and compound interest calculations, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any unanswered questions, concerns, or requests, just place it in the comment section below, and we'll be more than glad to respond. We update videos to our YouTube page on a consistent basis. If you would like notification for our latest updates, don't forget to subscribe to our channel. More great math resources can be found on mathgotserved.com. That's our website. Thanks again for watching, and have a wonderful day. Goodbye.